Good morning, class. We are looking at exam 4 review covering sections 4.4 to 5.4. Optimization problems, antiderivatives, the fundamental theorem of calculus, the substitution. First, reminding everyone of basic integration formulas. A constant gives you kx plus c. Power rule gives you 1 over n plus 1 x to the power of n plus 1. If you have a constant multiple, you can keep it inside or outside. The integral sign makes no difference. The same thing with the sum and difference. You do them term by term. X to the power minus 1 is the same as 1 over x. The integral is the natural log e to the power of kx. For differentiation and integration, they are the same, except in the case of a differentiation, we multiply by k. Integration, we divide by k. Sine gives you minus cosine. Cosine gives you sine, so on and so forth. We have FTC, fundamental theorem of calculus. There are two parts. One says the derivative of the integral gives you the function back. The dx of the integral of a to x, f of t dt is f of x. The other one is the definite integral, which is a number. The integral of a to b, f of x dx is capital F of b minus capital F of a, where capital F prime is lowercase f of x. And the substitution rule, which is the reverse process of the chain rule, and that says the integral of f of g of x, g prime of x dx, where g of x is u and g prime dx is du, is the integral of f of u du, known as the substitution. I want to discuss optimization problems. And to do that, first I want to remind you that whether we use the first or second derivative test, if we have one extremum and it's an open interval, a local becomes absolute. Here's a few examples as far as the concept is concerned. We want to find two numbers whose sum is 54 and whose product is a max. First, you have to define your variables. X and Y represent the two numbers. You want to maximize the product P equals X, Y. And the constraint is the sum is 54, X plus Y must be 54. Another example, if 5400 pi inch squared of metal is used to construct a cylindrical storage drum, what is its maximum possible volume? You have to define your variables again. So this is the shape, here's the radius, here's the height, and you want to maximize the volume. You should know the formula is pi r squared h. Now, the amount of material refers to the gift wrapping concept, the surface area. The surface area for this cylindrical shape is the area of the base, pi r squared times 2, the top and the bottom. And the lateral surface is, if you cut it open, becomes a rectangular shape where the bottom is the circumference, or 2 pi r, and times the height. And so subject to constraint, the surface area is 2 pi r squared plus 2 pi r h, and it equals to this number. And you work on that. Another example, a farmer wants to fence a rectangular field beside a river with 2,400 feet of fencing. The river itself will be one of the four sides. What dimensions will give the largest area? So you want to define your variables. You do the drawing and you say X represents the width, Y represents the length. We want the area to be maximized. So maximize area equals X times Y. The restriction, the constraint is that we have 2,400 feet of fencing. That means the perimeter, which is normally 2x, 2 times the width, plus 2 times the length. However, in this case, 2 times x, but 1 times y, because one side doesn't need fencing, and therefore 2x plus y equals 2,400. And that's defining variable, explaining what you have. And now we use the constraint to solve for y, and we put it into the objective function to make it a function of one variable. You always have to figure out your domain. The domain is between 0 and 1200 because X represents dimension must be positive. And if you set this one equal to 0, X becomes 1200. And if you choose X to be larger than 1200, this becomes negative, which is one of the dimensions can't be. So you have the open interval of 0 to 1200. You distribute, you get it ready for the next step, which is finding the critical points by differentiation is 2400 minus 4x. When you set this equal to 0, then the critical point becomes 600. You have an open interval with one critical point, so local becomes absolute. The best course of action is to go with a double prime. It's independent of x, so it's always negative, it's always concave down, and therefore it gives you the maximum because it looks like that. So maximum occurs when x is 600, you put it into here, and y becomes 1200. And the maximum area is the product of the two numbers, 720,000 square feet, because the product of 600 and 1200 is that. So it's pretty straightforward. From a thin piece of cardboard, 10 centimeters by 10 centimeters, square corners are cut out so that the sides can be folded up to make a box. What dimensions will yield a box of maximum volume? What is the maximum volume? So we have to do the drawing. We have to define the variables. We have a 10 by 10. So this is 10, this is 10 centimeters. You cut out the X here and here. That means another X here. So this is 10 minus 2X because two of them is out, the same thing here. You fold it up, you make it into a box, a rectangular solid with the height of X, the width and length of 10 minus 2X. The objective is to maximize the volume of a rectangular solid, which is the length times the width times the height. Subject to the width equals the length equals 10 minus 2x, and the height is x. Change the length and width, change the height accordingly, and you get the volume as a function of x, x times 10 minus 2x quantity squared. The very first thing we need to know is what is our domain. First and foremost, if you go back to this is 10 by 10. If you cut it in half, it becomes 5. And if you cut it in half, it can't make it into a box. So x must be less than 5 on the one hand. On the other hand, it must be positive. X can't be 0 because even if x is 0, you're not cutting anything, you're not making up anything to make a box. If you set 10 minus 2x equal to 0, also gives you the same thing. X equals 5. And it has to be less than that because 10 minus 2x is one side, the width or the length. So we have this domain, which is an open interval of 0 to 5. Let me actually erase my work because we need the space. So this, we are going to square it, and it's a squared plus 2ab plus b squared. 2ab plus b squared, plus b squared If it's negative, this becomes negative. Therefore, again, refreshing your memory. Squared is 100. 2 times the product of the two is minus 4dx plus 4x squared. Now multiply this by x, you get 100x minus 4dx squared plus 4x cubed. You put the 4x cubed the first in descending order, and we call it v of x. We are going to differentiate because we want to find the critical points. So what is v prime of x? 4 times 3, 12x squared, minus 40 times 2, 80x, minus 80x, plus 100. To set this equal to 0 and solve, we are going to factor the 4 out because 12 minus 80 and 100, they have 4 in common. Gives us 3x squared here, minus 20x here, plus 25 here. To factor this, notice 3 is a prime number. Therefore, this is factored as follows. 3x and x. 25 is the product of 1 and 25 or 5 and 5. Both of them must have the same sign because positive. That means both of them are positive. Both of them are negative, one of the two. And because this is negative 20, it ends up being negative. So work on it such that the middle terms add up in the following manner. Notice this is what? Minus 5x. This is what? Minus 15x. And the question is, do they add up to negative 20x? They do. This is a trial and error, and that's not the only way, but that's the fastest. And so when you set this equal to 0, it results in two answers. Set this equal to 0, either x is 5/3 or x is 5. And according to this, x cannot be 5. So number 5 is out. We have an open interval of 0 to 5 with one critical point. Local becomes absolute. We can do the first or second derivative test. Second is easier. V double prime is 24x minus 80. And remember what you should do. You should evaluate this, which means you have to evaluate it at x equals 5/3 just to see if it's positive or negative. So V double prime of 5/3 is 24 times 5/3 minus 80. This is 8. 8 times 5, 40. Minus 80 is negative 40. We don't care it's negative 40, negative 1, or any other number. We just want the sign. Negative means concave down, means maximum, because it looks like that. So we proved it's a local max. Because it's one critical point and an open interval, it's an absolute max at x equals 5/3. So if x equals 5/3, the width and the length should be 10 minus 2 times that. And that gives you 10/3, right? So minus 10 is 30 thirds. So the answer is 20/3 inches. So the dimensions are 5/3 by 20/3 by 20/3. And the volume is the product of the three numbers, which is 5 times 20 is 100 times 20 is 2000. 3 cubed is 27. This is the exact answer, class. 2000 over 27 or 74 and 2 over 27 cubic centimeters. You must always write the units and keep it as exact number unless they ask for decimals, in which case you always go to the next one to make a decision about the decimal. For example, 2 decimals, you go to the third one to make a decision. Find all functions g such that g prime of x is 4 sine x plus 2x to the power of 5 minus square root of x over x. And I put some integral formulas for you here. So here's the methodology, everybody. Sometimes you will need to simplify first, factor, cancel, remove radical notation, etc. Sometimes you will need to integrate using substitution. So in this case, we are going to make up two fractions. This, we keep it, this one over this, minus this one over this, and this will simplify to 2x to the power of 4. This one, we're going to change this to x to the power of 1/2. And bear in mind, the exponent for the denominator is 1. So this is x to the power of 1/2 minus 1. So we have 4 sine x plus 2x to the power of 4 minus x to the power of negative 1/2. So far, we've done nothing but algebra. And so to integrate or find the antiderivative, g of x becomes the integral of the right side times dx. And I can't emphasize this enough. You have to have a dx here. Otherwise, you can't integrate. Now, sine, the derivative is cosine. The integral is a negative cosine. So minus 4 cosine x. 2 over 5 x to the power of 5 minus 1 over negative 1/2 plus 1 x to the power of negative 1/2 plus 1 and a constant. And again, this is the only calculus step. Everything else was algebra, and so is the next step. So we are going to look at this one and change it accordingly. This becomes 1/2. The reciprocal of that is 2. So we have minus 4 cosine x plus 2/5 x to the power of 5 minus 2 x to the power of 1/2 is square root of x and a constant. And that's the final answer. The integral of 2x to the power of 4 plus 3x cubed minus 7x squared plus x minus 5. You are using the power rule. 2 over 5x to the power of 5 plus 3 over 4 x to the power of 4 minus 7/3 x cubed plus x. Remember, x has exponent 1, therefore 1/2 x squared minus 5x plus c. X minus 5 squared, we square that. We've seen this many times. So this is x squared minus 10x plus 25. X squared, 1/3 x cubed minus 10 divided, just remember, just like this one, the exponent is 1 minus 10 divided by 1 plus 1 or 2 minus 10 divided by 2 minus 5x squared plus 25x and a constant. This is really kx, this concept, everybody. Exponentials. Whether you differentiate or integrate exponential functions with base e, the answer is itself. However, in the case of differentiation, you multiply by k. This is k, the coefficient of x. In the case of integration, you divide. So when you have integral of e to the power of kx dx, the answer is itself, but divide by k and a constant. So in this case, the answer is itself. Divide by 4 and a constant, we get 1/4 e to the power of 4x plus c. In this case, Again, the answer is itself. We divide by -3, which gives us -1/3 e to the power minus 3x and a constant. In this case, we rewrite x to the x over 2 as a half of x. So we know that the coefficient of x is 1/2. And according to this, we are going to write 1 over 1/2 e to the power 1/2 x and a constant. 1 over 1/2 is 2. Again, the reason we write it in this fashion because we want to make sure it's clear what we are dealing with. Here's another example that we are going to rewrite to make it clear. We are going to rewrite this as 2 times 1 over x. So we are here, everybody. We are dealing with logs as the result. So 2 times, now the integral is natural log of absolute value of x and a constant. What about this one? Same thing. We rewrite it in the following manner. So 1/2, now integrate 1 over x dx, which is a natural log. So 1/2 natural log of absolute value of x and a constant. So the reason we write it in this fashion or in this fashion or in this fashion to make it clear, what is it that we are dealing with? We want to evaluate the integrals. We are dealing with the definite integral, and to find the definite integral, we don't need the constant. We come up with the antiderivative, which is 1 over 8 x to the power of 8. And we plug in 1 gives us 1, 0 gives us 0, and we get 1 over 8. Again, it's important to pay attention to this tip. Even if we use another antiderivative, that means a general form, capital F of x plus c, in the evaluation, the result will be the same because capital F of b plus c minus capital F of a plus c, those c's cancel out. We get f of b minus f of a. What about this one? The integral of x to the power minus 1 dx from 1 to 2. Again, notice this means 1 over x. This means a natural log. And the limits, 1 and 2 are both positive. If you lose the absolute value, makes no difference whatsoever. You should know this is 0. ln2 is an exact answer. You want to keep it as exact, okay? Unless otherwise they are asking you for a specific number of decimals. If they don't, exact answer is ln2. Again, we are looking at the same question as B with different limits. However, when we plug in, we keep the absolute value. The reason why natural log of a negative number is undefined. You must keep it with the absolute value, which results in ln1 minus ln2. And the answer is precisely minus ln2. The integral of sine x dx from 0 to pi, the derivative is cosine, the integral is negative cosine. Let's keep this negative one out and plug in. Cosine of pi is -1 minus cosine of 0 is +1. So they result in -2. This negative outside makes it positive. You want to integrate or differentiate, makes no difference. You're going to cut this into 3 fractions. 1 minus 7 over x, 2 over x squared. To become clear what we are dealing with, minus 7 over x, we write it as minus 7 times 1 over x. And 2 over x squared, to get it ready for the power rule, we're going to write it as 2x to the power minus 2. We're dealing with dx, so 1 gives us x. Minus 7, 1 over x gives us natural log. What about this one? Two over negative 2 plus 1, x to the power of negative 2 plus 1. Negative 2 plus 1 is negative 1. 2 over negative 1 makes it minus 2, x to the power minus 1. So minus 2 over x and a constant. The integral of 1 plus cosine t minus secant squared t dt, 1 becomes t. Cosine, the derivative is negative, but the integral is positive sine t, minus secant squared. Remember, the derivative of tangent is secant squared, so that gives you minus tan t and a constant. This is the last point. What about the integral of cube root of x minus sine x dx? This has to be changed to x to the power 1/3 to get it ready for the power rule. So this becomes 1 over 1/3 plus 1, x to the power of 1/3 plus 1. This one minus negative cosine x. You could write plus in one shot, but I just wanted to show you this negative sign remains, and this is because of the cosine, okay? So minus negative cosine, if you will. And so obviously this becomes plus. What happens here? 4/3. 4/3. The reciprocal of that, 3/4. So 3/4 x to the power of 4/3. X to the power of 4/3, we can write it as cube root of x to the power of 4. Minus and minus becomes plus. So 3/4 cube root of x to the power of 4 plus cosine x plus c is the final answer. Initial value problems, dv dt is e to the power minus t times 1 plus e to the power of 2t, v of 0 equals 3. First, let's discuss the differential equation. Every problem we've done so far, in essence, with the integration has been differential equation. Any equation containing a derivative is called a differential equation, or DE. A function which satisfies the equation is called a solution to the differential equation. An initial value problem is a differential equation along with a specified value of the unknown function called the initial condition. So with this, it becomes an initial condition. So for now, we're going to ignore that. We are looking at this part, and we are going to put the dt on the right. We are going to integrate both sides, which results in v of t on the left. What about this one? Is the same thing divided by negative 1 becomes minus e to the power minus t. This is itself and a constant. And what you're looking at, everybody, is a general solution. Meaning you're dealing with a family of functions. You have infinitely many different functions. However, the effect of this, which is just one pair, 0, 3, is to help us find the constant. Plug in. As you know, e to the power of 0 is 1, so this is minus 1 plus c. These two cancel each other, right? So c becomes 3, and so replace it here. And now this is a particular solution. So in short, the effect of this initial value, the effect of one pair, is to help us with the general solution, getting rid of the constant, finding that, and go to one function instead of infinitely many different. That's the effect of that. Substitution, as it was mentioned, is the reverse process of the chain rule. So the integral of f of g of x, g prime of x dx, where g of x is u, g prime of x dx is du, is the integral of f of u du. The tip is look for a function u equals g of x anywhere in the integrand, and its derivative du, or g prime of x, multiplied by dx. Now, first and foremost, when substitution is a must, step one, you have to write u and du. So what is u? What is du? Has to be written down. Step two, if in a case like this, you're dealing with polynomials, the more complicated one, in this case, x squared plus 5 is a choice of u. Needless to say, you notice the derivative of that is 2x. So let u be the more complicated polynomial, x squared plus 5. Its derivative du dx is 2x. Therefore, du is 2x dx. To make it clear what we are dealing with, we are going to move the 2x so it becomes clear this is u. This entire thing in blue is du. So you have u to the power of 30 du. And we can use the power rule on that, which is 1 over 31. U to the power of 31 on a constant. That's the power rule. Replace the u, 1 over 31, x squared plus 5 to the power of 31 plus c is the final answer. I have a couple of fractions. Rational functions are the cases here, but even if you have any type of a fraction, the first step remains the same, which means simplify if you can. So you're going to factor the top, you're going to factor the bottom, and simplify if possible. In this case, notice 2 is a prime number. Therefore, it's a simple case of a 2x and x. This is a prime number, so you have to go with 1 and 3, or 3 and 1. One of them negative. So you do the trial and error, and you check the middle term in the following manner. These two give us 3x. These two give us negative 2x. And the sum of these two must be this. And it is. Okay. So that's factored. Now, the top can't be factored out. So, and you notice if you differentiate the bottom, we get 4x plus 1, which is the numerator. So u is the denominator. U is 2x squared plus x minus 3. Du dx is 4x plus 1. And therefore, du is 4x plus 1 times dx. To make it clear what we are dealing with, we're going to put the dx next to the top. And by the way, please understand dx is never, ever a part of the denominator. This whole thing is du, and the bottom is u. And this is a simple case of a natural log. The integral of 1 over x dx. So in this case, the integral of 1 over u du. So it's a natural log of u and a constant. U is replaced. We are done. We keep the absolute value because the expression may or may not be positive. It has both possibilities. What's the difference between these two? Well, I can factor the numerator also, in which case the common factor of x minus 1 must be dropped. So the difference between A and B is that A cannot be simplified, B can, and it must. Now, when we can't simplify it further, then the choice of u is the denominator. You know the derivative is 2 du becomes 2 dx. And what you really have up here is 4 dx. So you can rewrite this as 2 times 2 dx in the times 2 dx as follows. We have 4 dx in the numerator. It's 2 times 2 dx. So you can put the 2 out, or it doesn't matter, you keep it in. The fact of the matter is the numerator is now du. And again, we go back to this and we say 2 times the natural log of u and a constant, and you keep the absolute value and replace the u with 2x plus 3, because 2x plus 3 can be positive, can be negative. So the final answer is 2 natural log of absolute value of 2x plus 3 plus a constant. We are done. Now, what I want to look at, I want to look at the reciprocal of this guy, which becomes the reciprocal of this guy. And the reason I want to do that, because I want you to see that in this case, we did need simplification and then the substitution. In this case, we don't, because 2x over 4 is half of x, and this is 3/4. We've already done that. X gives you half of x squared times 1/2 is 1/4 x squared plus 3/4 x and a constant, meaning you need a substitution, you don't. So don't assume you always need a substitution with a fractional expression or rational expression. And that's the key here. All right, again, I have a couple of fractional expressions. This one is a fractional expression. This is a polynomial. The process is the same. There is nothing to do to simplify. U would be the denominator. As you know, the derivative of that is e to the power of t. Therefore, du is e to the power of t dt. We rewrite this by putting the dt next to e to the power of t. We are telling our reader the numerator is du, the denominator is u. Again, we've seen this many times before. The answer is a natural log of absolute value of u plus c. Replace it. And if you want to lose the absolute value sign, you can, because 5 plus e to the power of t is a positive expression. This one you want to simplify by factoring. The denominator can't be factored because b squared minus 4ac must be a perfect square for it to be factored. And I've explained that before. Let's just quickly remind everybody of that. If you have ax squared plus bx plus c, b squared minus 4ac must be a perfect square. In this case, a equals 1. We're looking at this one. B equals 2, C equals -1. If this is a perfect square, it can be factored. 2 squared minus 4 times 1 times -1, and it gives you +8, which is not a perfect square, cannot be factored. So let u be the denominator. The derivative is 2x plus 2. Du dx is 2x plus 2, or 2 times x plus 1. Therefore, du is 2 times x plus 1 times dx. So now, first, we're going to put the dx at top so it becomes clear what we are dealing with. Second, we notice that everything is in order except we don't have number 2. 2 is missing for du. And as I've mentioned many times before, when a number is missing, it's not a big deal. In most texts, they solve for dx. You don't have to. 2 is missing, throw in the 2. How do you undo it? It's reciprocal. So the product of these two numbers is 1. We are in good shape. You can only do that to numbers. And now you are dealing with half of the integral of du over u, which is the same as here, and the rest of it natural log. And replace the u, you get 1/2 natural log of x squared plus 2x minus 1, and a constant. We are done. Also on the same page, I want to look at the reciprocal of part A. If we had the reciprocal of part B, you have to do long division class. For this one, you look at this part becomes 5 e to the power of negative t, and this part is 1. So you make up two simple fractions. This one and this one. And the integral of this one is minus 5 e to the power minus t. This one is t and a constant, and we are done. So compare and contrast. This, we must use substitution. This, there is no need for that. Let's integrate. And before we do that, let's pay attention to d theta, which is telling us the independent variable is theta. Therefore, 5 gives us 5 theta. So pay attention to that. 2 cosine gives us 2 sine theta, and a constant. We are done. The purpose of this question was just to remind you, pay attention to your independent variable. As I mentioned before, anytime we have an exponential form, the exponent is the choice of u. Its derivative is 5x to the power of 4, du dx. So du is 5x to the power of 4 dx. We're going to move x to the power of 4 next to dx. And we notice that everything is in order except number 5 is missing. Because it's a number, we can put in the number in here. Again, you can solve for dx. That's what everybody does. Most everybody does. But I'm telling you an easy way. Just throw in the 5, undo it with 1/5. It's a lot faster. And so what you have now, you have 1/5 the integral of e to the power of u du. And this one, the answer is itself. So 1/5 e to the power of u, and a constant. And u is replaced with x to the power of 5 minus 2. And we are done. We are looking at sinusoidal functions. Again, we have them next to each other for a simple reason. When you have either sine or cosine, just one of them, and the argument as an exponent, the argument is a choice of u. Its derivative is 2x. Therefore, du is 2x dx. We move the x next to x squared to make sure we see what's going on, and we notice everything is in order except number 2 is missing. Again, you can solve for dx and move on, or just plug in 2, undo it with its reciprocal 1/2. So we are looking at 1/2 the integral of sine u du. which is negative cosine. The integral is negative cosine. So minus 1/2 cosine u plus a constant, and u is replaced with x squared as always. You can differentiate the result and it gives you the same answer except the dx. It gives you the integrand without the dx. What happens when we have both sine and cosine? The one that has the exponent is a choice of u without its exponent. Sine has the exponent. So that's a choice of u. What is du? The derivative is cosine x. Du is cosine x dx. You really don't have to do much. This is u squared. This is du. The power rule says the answer is 1/3 u cubed plus a constant. Replace the u with sine and you're done. Now, what about this case? Again, similar to what we just saw, but I want to make sure that you see what's going on. Again, we have sine and cosine. This time, cosine has the exponent. That's the choice of u. The derivative of cosine is negative sine x. So du becomes negative sine x dx. So when we look at this one, everything is ordered. We don't have a negative sign. So we are going to rewrite this. And we're going to put this in a parenthesis. We put the negative in, negative out, because the product is positive 1. In other words, you're putting -1 in here. The reciprocal of -1 is itself -1. And so you have minus integral of u to the power of 20 du, which uses, again, the simple case of a power rule, everybody. And so it's -1/21 u to the power of 21 plus a constant, and u is cosine. So -1/21 cosine to the power of 21x plus a constant. I put a negative in a different color because we are not losing that. See, it's here, it's here, it's here, it's here, and we want to make sure that we don't lose that. Evaluate the integrals. What happens when ln x is involved? It is always the case that ln x is the choice of u as far as this course is concerned. Now, we know the derivative of ln x is 1/x, therefore du is 1/x dx. And there are two ways to write that. You can write it 1/x dx or dx/x. We are going to rewrite this so we can see all the components. This is ln x to the power of 2, and we combine these two in 1/x dx. Whether you put it in this format or you put dx/x makes no difference. Now you see it's u squared du. Again, simple case of a power rule. The answer is 1/3 u cubed and a constant. You replace the u. And I can't emphasize this enough. We don't want to mix it up. This means ln x times itself 3 times. Please understand the following. Ln of x to the third is not equal to ln of x cubed. Okay, this is the same as 3 ln x, so don't mix them up. Here's the next one, and anytime you have a fractional format, your goal is to simplify if possible. And in this case, we can't. At the same time, we notice the derivative of the bottom is the top. If you differentiate this, you get the top. E to the power of x is itself, e to the power of minus x is minus e to the power of minus x. So u is the bottom, and du is the top times dx. And so we rewrite it by putting the dx next to the top And this is simply du over u, which is again a simple case of a natural log as the answer. So ln of absolute value of u and a constant, replace the u, ln of e to the power of x plus e to the power minus x plus c. Whether you have an absolute value or not makes no difference because this expression is positive. If you don't know it, you keep the absolute value. As I mentioned, you're dealing with a natural log. That's a choice of you. If you want to differentiate that, I hope you realize you get 1 over x plus 1 times the derivative of the inside, which is 1. So the derivative or du dx is 1 over x plus 1. So what is du? 1 over x plus 1 dx. And so we are going to rewrite it by putting the dx over x plus 1 separate. Again, notice this format versus this format. On purpose, I have two different formats. This is good. This is good. Both of them mean the same thing. This is u. This is du. And it's a simple case of a power rule, 1/2 u squared. Now, I can go with 1/2 u squared, put the u back as ln of x plus 1 and go with the original limits, or find the new limits. The new limits are, if I put the 0 here, I get ln 1. Which is 0. If I put 1 here, I get ln 2. So 1/2 u squared with the limits. And as I said, this is 0, so it has no bearing, everybody. This one you put ln 2, and it's half of ln 2 to the power of 2. Please understand this is in the parentheses, and it's an exact answer, everybody. Don't change it unless they have asked you. This is an exact answer. Exact answer. It's not an approximation. Keep it as an exact answer always. A bacterial colony increases at the rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. As you recall, rate in general means the derivative when it comes to calculus. So we are going to say if this is the derivative, capital R of t represents the population, and capital R prime or lowercase r of t represents the growth rate, and R of 0 equals 800. So according to the accumulated change theorem, the amount of increase over the course of 12 hours is the integral of 0 to 12 lowercase r of t dt. And we are ready to do the math. And as you know, the methodology is that when you're dealing with the exponential, the derivative and the integral are the same, except in this case, we divide by 0.4. In the case of a differentiation, we multiply by. And so 22 divided by 4 or 5.5. You plug in 12, you plug in 0, you do the math, you put it into a calculator. Of course, this one becomes e to the power of 0 or 1. But nevertheless, you put it into a calculator, and because you're dealing with the number of bacteria, you go with the whole number, you round it accordingly. But there were initially 800 bacteria, they add up. And so the answer is the sum of the two numbers. R of 12 is 800 plus 663 equals 1463. The second method. The second method is to actually find capital R of t in general, and that's the integral that we are looking for. And since we already have this, the answer is this one plus a constant. With the initial value of R of 0 equals 800, we can find the constant. As you can see, this is 1, this is 5.5. With what number is 800? 794.5. Therefore, capital R of t is this plus this. And the advantage of that is that if we want the population at 10 hours, 12 hours, 15 hours, 20 hours, just replace the t with the number that you want. In this case, it's 12, and that gives you the same answer. But as I said, they want it at different hours. It can happen. Breathing, we can model the rate of airflow into the lungs by the function f of t equals half of sine 2 pi over 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Note or hint, the time for inhalation is half of the cycle. On a normal basis, is half of it. It takes, the whole thing takes 5 seconds, half of it in, half of it out. So 5 halves. This number divided by 2. Total amount of air would be the integral of 0 to 5 halves f of t dt. Okay. So that's the total amount, because that's the rate, okay, liters per second. And so we are going to integrate this, and we are going to use the substitution because it's sine of not t, but rather 2 pi over 5t. So we let u be this expression, 2 pi over 5t. As you know, if I want to differentiate, du dt becomes 2 pi over 5. Du dt is 2 pi over 5. So what is du? 2 pi over 5 dt. So what am I going to do? Well, I'm going to make sure that dt looks like that. So first of all, this 1/2 that was there, it's inside or outside the radical makes no difference. It's a number, it's going to remain. I'm going to write this sine 2 pi over 5 times t, and I'm going to write this t dt. When I look at this, I don't have 2 pi over 5. So I'm going to put 2 pi over 5 here. Why? It's a number. So if I put 2 pi over 5, I need its reciprocal, 5 over 2 pi outside. So you can't just put 2 pi over 5. You have to put its reciprocal. The product of these two is 1. And so now these two give us 5 over 4 pi. This will give us sine u du. But I'm not writing the limits yet, because these limits, 0 and 5 halves, are not the same here. So what do? You plug in here. If I plug in 0 here, I get 0. So the lower limit remains as 0. But what if I put 5 halves here? I get 2 pi over 5 times 5 halves. So the upper limit is pi. Okay. And of course, sine, the integral is minus cosine. So I'm going to take this negative out, make it minus 5 over 4 pi. Then cosine of the top pi minus cosine of the bottom 0. And as you know, this is negative 1 minus 1. This is negative 2, everybody. Okay. And negative 2 times negative 5 is positive 10 divided by 4. We get 5 over 2 pi. Again, exact and approximation. Exact and approximation. And we should distinguish between the two. You always go with exact unless they ask you for an approximation. Okay, everybody? Always go with exact. This question was done, and now we are going to evaluate it. So because it's t, we have t plus sine t. I hope you remember that. And we are going to evaluate it from 0 to pi over 2. So we are going to plug in pi over 2, and we're going to plug in 0. Uh, 0 sine 0, this goes to 0. Sine of pi over 2 is 1. And that's the exact answer again. And you're done. You want to write the exact answer, everybody. What about this one? You change this to x to the power 1/2. This has exponent 1. 1 and 1/2, they add up to 3 halves. Now they are ready for the power rule, which is 5 divided by 3 halves plus 1 x to the power of 3 halves plus 1. 3 divided by 1/2 plus 1 x to the power of 1/2 plus 1. Okay. And of course, from 1 to 4. Let's see what happens here. We are going to write this as 5 halves. This one has 2, 3 halves. This one has 2. And we are ready to plug in 4 and plug in 1. Now this is elementary algebra. Okay, everybody? So we plug in 4 and we plug in 1, and we want to evaluate 4 to the power of 5 halves means square root of 4, or 2 to the power of 5, or 32, or 2 times that is 64. 4 to the power of 3 halves means square root of 4, or 2 cubed, which is 8, times 2 is 16, minus, this is 1, this is 1. So you're looking at 2 and 2, 4. And the answer is 76. Let me quickly remind you of what we did last time, the integral of 3 to 4x squared of 25 minus x squared. This is just to remind you what happens again with the limits. So 25 minus x squared is the u, the derivative is minus 2x, du is minus 2x dx. We move the x next to the x, and so negative 2 is missing, you plug in, and it's clearly has to be undone with its reciprocal. So you can't just plug in negative 2. And so you have the following. This is u to the power 1/2. We've done this many times before. So negative 1/2, this is 1 over 1/2 plus 1 u to the power 1/2 plus 1. You can even go to the previous page. We had it done, okay? So it's really not a big deal. So 1/2 plus 1 is 3 halves. So let's just do that. So this is 3 halves. And this is the reciprocal, therefore 2/3. And this is negative 1/3. And you can go back to the original variables, original variable and original limits. However, if you want to go to the new ones, if you plug in 3 here, 3 squared is 9, 25 minus 9 is 16. If you put 4, you get 16, 25 minus 16 equals 9. And you can evaluate it this way by plugging in 9 and 16 and evaluate them. 9 to the power of 3 halves means square root of 9, or 3 cubed, 27, minus 16 to the power of 3 halves means square root of 16, 4 cubed, 64, so minus 37, and their product is 37 thirds. And let me quickly go over this one. We have done it also. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimensions that minimizes the amount of material used. A rectangular solid, also known as a prism, the volume is the width times the length times the height. Gift wrapping or surface area. You have the width times length. For one side, they have two of them. Height times length, height times width, and each one is times 2. If all sides are equal, it's called the cube. The volume is s cubed. The surface area is 6s squared. So in this case, we want to minimize the surface area, which first we are going to define x and h. The reason it's x and x because we are claiming it's a square base. So the surface area gift wrapping would be x times h, and we have 4 of them. They're identical, 4 times xh. We have the bottom x squared, the top x squared, 2x squared, but it's open top, so 1x squared. So we want to minimize s, which is 4xh plus x squared, and it's subject to the constraint that x times h, the volume must be 32,000. We solve for h. Because we want this one to be a function of x, we put it in. This x cancels out this x, this becomes x, this goes away. 4 times 32,000 is 128,000. And because we want to get it ready for the next step, we are going to write this as 128,000 x to the power of -1 plus x squared. And x represents dimensions, must be positive. What is the next step we want to make it ready for is differentiation, because we are looking for the critical point. So the product of these two, -128,000 x to the power of -2 plus 2x. So this is S prime. And to find the critical point, you set this equal to 0 and where it's undefined. So this is over x squared. And when you can take a common denominator, this is what you end up with. So S prime is 0, the top is 0, S prime doesn't exist, the bottom is 0, the bottom gives you 0, which is not in the interval of 0 to infinity. So you set the top equal to 0, which gives you 2x cubed equals 128k, x cubed is 64k, and the critical point is 40. So you have one critical point. You check with the second derivative test, 256,000 x to the power of -3, because you go back here, everybody, and you multiply these two. And you just want to plug in to see if it's positive or negative. So when you plug in, even if you don't evaluate it, I hope you recognize this is positive with the 2 becomes positive. And that means concave up. Concave up looks like that. That means minimum occurs when x is 40. If x is 40, you put it into this, and h becomes 20. And the dimensions are 20 by 40 by 40. And s, if you put it in, becomes 4,800 square centimeters.